Hello all, welcome back to Coder. Today let us solve the Lead Codes daily challenge, and the problem is palindrome partitioning. Given a string yes, partition yes, such that every substring of a partition is a palindrome. Return all possible palindrome partitioning of yes. So we want to find all the palindrome partitions, that is in A, B, when we partition each substring, then that string should be also a palindrome, else we cannot form a palindrome. So what we can do is we want to find the try out all possible ways. So to try out all possible ways, we can just tend to apply a recursion. So what we can do is we can consider each part of the index and try to partition when if when we have an index I and when we have an index j, then a string that is formed between I to j, if it is a palindrome, then we can start a next recursive call from j plus 1, and that it goes on, and we will try to do the we will try to partition for each and every index, and we will try to generate all possible partitions. And once it reaches the end of the string, then we tend to put the entire vector into a resultant vector. So that is how we can generate all the all palindrome partitioning. So what we can do is first we can have a vector of vector strings. So we can have a vector of vector string that is going to be the resultant vector, and that is going to be the returned as our answer. And we can also have a vector of strings. That vector of string, that is going to be our data structure. Currently we can just try to put each and every partition string into this data structure, and once I have reached the final index, I can just insert this data structure into our resultant. That is what this data structure represents. And we can call the recursive function. I'm going to call it as palindrome partition of string yes, and it going to start from the index 0, and resultant is passed, the data structure is passed, and I'm also having an empty string. This empty string is nothing but I think we don't want to have an empty string. Yeah, we can actually go like this itself. So we can have the function to be private, since we don't want to expose this function outside of this class, and that is going to be a void palindrome partition of string yes, and int I, it is going to be the index, and vector of vectors of strings, vector of string res, and vector of string data structure. So these are the parameters that are passed. Next, what we can do is we can have a base case. What is the base case? If my I have reached the s dot size, then this data structure will be containing the partition strings, which are palindromes. So we can push that data structure into my resultant vector and return. So this is going to be my base case. Now next what we can do is we can try to partition each and every index string and check whether this string is a palindrome, whether this partition string is a palindrome. For that we can have the cur str, or we can say it as string cur. This current is going to be the palindrome, or we can say it as palindrome, string palindrome. This string palindrome is nothing but for each and every index from starting from I, I'm going to go till s dot size, the length, and k plus plus. And what I'm going to do is I'm going to append this current character into my palindrome string, palindrome of s of palindrome plus equals to s of k. And when this palindrome is going to be a palindrome, this palindrome is a string, and if this string is a palindrome, that I want to check via a function. We don't know that this string is going to be a palindrome or not, or else if it is going to confuse, we can have it as cur itself. This is going to be the current string, and I'm going to have a function palindrome. That if that palindrome, I'm going to pass this current string, and this will check whether this current current string is a palindrome or not, is a palindrome or not, and that is what this function is going to do. And if this string is going to be a palindrome, then we can partition at this index k. After this index k we partition it, we can just go to the next index, that is nothing but the k plus 1. So we can call the function palindrome partition. String s is passed, the next index is going to be k plus 1, and then the resultant vector and the data structure. So data structure is nothing but data structure dot pushback of this current string, and once it comes out we want to pop back. This is going to be the backtracking that we are going to do. So basically this solution is a backtracking solution only. So once we come out of this recursive function, we are just backtracking, that is we are just popping out this string from our data structure and trying to append the next character s of k into our current string and try to do the same process repeatedly for every such index if it is a palindrome or not. So we can, now our sole purpose is to define this function is palindrome, and that is very simple. Bold is palindrome. This function takes a string and name it as pal, and yeah, that's it. And my low is going to be 0 and my high is going to be pal dot size minus 1, and we can just simply check while my L is lesser than height, sorry, L is lesser than h. We can just go if my pal of L is not equals to pal of h, then what we can do is we can just return false. This is how we can check whether it is a palindrome or not. So we can have this function and we can have this check. If it is not, we want to move the pointers L plus plus H minus minus, and we can finally return true, because this is going to be a palindrome if it ends, if it gets end in this with this while loop. So this is how we can have this palindrome function, and this is going to be our palindrome partition recursive function. This is going to be a backtracking solution, and we are having a current string and we are appending each character, and if string is a palindrome, then we will push that into our data structure and do our next recursive call starting from the index k plus 1, and while coming back we will just pop out, so that we will try to generate all possible strings such that they are palindromes. And now let us try to run our code and see whether it we get our cases right. Yeah, it gets accepted, so let us submit the code as well, and these constraints are very small, so it basically gets accepted, I guess. Great, it gets accepted. So hope you like the solution, and let me know in the comments if there are any suggestions. Let us see in tomorrow's lead code daily challenge. Until then, bye.